In this DeBacco University video, I'm going to be going over the steps required for drawing Lewis dot structures for atoms. You can see some couple examples here, but in this video, I'll give you the details so you'll be able to do that for any atom of your choosing. Alright, so what's the overall guide? Well, a Lewis dot diagram is a visual representation of the valence, which are the outermost electrons, in a molecule, showing how they are arranged around individual atoms and how they participate in chemical bonds. These structures use dots to represent valence electrons, or lines, or pairs of dots to represent shared electron pairs in covalent bonds. So when two electrons are being shared, typically between atoms, instead of doing a dot to dot, there'll be a nice line indicating that's a bond between those. We could see here chlorine, they have 7 valence electrons, so some groups of 2, and 1 over here. So if we count all those up, chlorine and the halogens, which is the family it belongs to, will have 7 valence electrons, so 7 dots for its Lewis dot structure. Now, how do you go about this? Well, first you want to find the element on the periodic table. The group number, or the column, tells you how many valence electrons the atom has. Now, an example here would be oxygen is in group 16, so it's got 6 valence electrons. We can see here, these are going to have essentially 8, except for helium will have 2, 7, and 6, and 5, and 4, and 3, and 2, and 1. Now, you might be a little tossed and say, well, this says 16. Why isn't there 16 valence electrons? You have to drop the 10s and essentially look at the 6 here. This will be group 17, but it'll have 7 valence electrons here for the halogens as an example. Now you want to write the element's symbol. So this represents the nucleus and the inner electrons. For example, for oxygen, you simply write O when that was found on the periodic table, or you might know it if it's one of the most familiar elements that you're working with. Then you want to place the dots around that particular symbol. So each dot represents 1 valence electron. Place up to 2 dots per side, that's including the top, the bottom, the left, and the right, and spread them out before pairing. So for example, oxygen gets 6 dots, 1 on each side, then you start pairing. So what does that kind of mean? Well, you start here with 1, then you go to 2, and then 3, and then 4, and then you start pairing. So 5, 1 and 5 will be paired, 2 and 6 will be paired, 3 and 7, and 4 and 8. In this other diagram here, the vacant positions are the empty boxes, and the electrons are represented by the darkened in circle. So again, we don't just put all the electrons in a line, we don't put them all down one side. We start at the individual areas there, we work our way around, and only then do we start to double up as we go around a second time to get to up to 8. Now, as just a general reminder, Group 1, hydrogen and lithium, have 1 valence electron, so they're only going to get 1 dot. Group 2 gets 2 dots. Group 13 through 18 have 3 to 8. They kind of vary. They're called, again, the transition metals. Helium is an exception, meaning it only has 2 valence electrons despite being in group 18, because all of the other elements in those noble gases will have 8 or a full octet. So hopefully this gives you a little idea of what to expect, and as you go through and do this, you'll become more familiar with it, and hopefully it'll become easier as you notice these key patterns.